flagpoles are 30 meters apart. The one has height 10 meters, while the other has height 15 meters. Two tight ropes connect the top of each pole to the foot of the other. At what height above the ground do the two ropes intersect? What if the poles were at a different distance apart? Solution. Case 1. The two flagpoles are 30 meters apart. The figure illustrates the problem. Let the flagpole of height 10 meters be AB, and the flagpole of height 15 meters be CD. The top of flagpole AB is tied to D, and the top of flagpole CD is tied to B. We assume that the flagpoles are at right angles to the surface of the ground. Let the point of intersection of the two ropes be P. We are required to find the height of P above the ground. Let us name the point where the vertical line from P meets the ground as Q. PQ will be perpendicular to the ground, so there is a right angle at Q. Triangle ABD and triangle PQD are right angle triangles, where we apply the trigonometric ratios. In triangle ABD, tan of angle 1 equals tan angle ADB equals AB over BD equals 10 over 30 equals 1 over 3. In triangle PQD, tan of angle 1 equals tan angle PDQ equals PQ over QD equals 1 over 3. Therefore, PQ equals QD over 3. We call this equation 1. Likewise, triangle CDB and triangle PQB are right-angled triangles, where we apply the trigonometric ratios. In triangle CDB, tan of angle 2 equals tan angle CBD equals CD over DB equals 15 over 30 equals 1 over 2. In triangle PQB, tan of angle 2 equals tan angle PBQ equals PQ over QB equals 1 over 2. Therefore, PQ equals QB over 2, equation 2. Equating the value of PQ from the two equations, we get QD over 3 equals QB over 2, equation 3. But QD plus QB equals 30 meters, or QD equals 30 minus QB, equation 4. Substituting 4 in 3, we get 30 minus QB over 3 equals QB over 2. Rearranging the terms, 10 equals QB over 2 plus QB over 3, or 5 QB over 6 equals 10. QB equals 12 meters. Substituting back in equation 2, PQ equals QB over 2 equals 12 over 2 equals 6 meters. The two flagpoles are at a different distance apart. Let us move the 10-meter flagpole and see what happens to the point of intersection. We first move the flagpole to the right and then to the left. We see something interesting. The different points of intersection are on a horizontal line. We can make a conjecture that the height of the intersection point will be the same, that is, 6 meters, whatever be the distance between the flagpoles. Let us now try to prove this using trigonometry. Conjecture. The height of the intersection point above the ground is 6 meters, irrespective of the distance between the two flagpoles. Let us now try to prove this using trigonometry. Now, BD is also unknown. Let us call this distance D. In triangle ABD, tan of angle 1 equals tan angle ADB equals AB over BD equals 10 over D. In triangle PQD, tan of angle 1 equals tan angle PDQ equals PQ over QD equals 10 over D. Therefore, PQ equals 10 QD over D. We call this equation 1. In triangle CDB, tan angle 2 equals tan angle CBD equals CD over DB equals 15 over D. In triangle PQB, tan angle 2 equals tan angle PBQ equals PQ over QB equals 15 over D. Therefore, PQ is equal to 15 QB over D, equation 2. Equating the value of PQ from the two equations, we get 10 QD over D is equal to 15 QB over D. Multiplying both sides by D and dividing by 5, we get 2 QD equals 3 QB, equation 3. But QD plus QB equals D meters, or QD is equal to D minus QB, equation 4. Substituting 4 in 3, we get 2 D minus QB equals 3 QB. Rearranging the terms, 5qb equals 2d, or qb equals 2d over 5. Equation 5. Substituting back in equation 2, pq equals 15qb over d equals 15 times 2d over 5 all over d equals 6d over d equals 6 meters. We see that d has disappeared from the equation, which means that the height of the intersection point does not depend on the distance.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you and let the math finally start mathing.